Welcome back to Maths with Mrs. J. We've been doing a series of videos on solving simultaneous equations. Now what that means is that you're wanting to find the unknowns that satisfy both equations, or sometimes you might have more than two equations. Graphically, what that looks like is a point of intersection of the graphs. So in our example in the previous video, we had two linear functions that graph obviously as straight lines, and the normal occurrence there is that they will intersect at one point and the x and y values of that point will constitute your simultaneous solution. There are two other possibilities if you have two straight lines. One is that the straight lines will be parallel and therefore there will be no point of intersection and hence no simultaneous solution. The other somewhat interesting possibility is that both lines coincide, they're the same line, in which case you have an infinite number of solutions that are simultaneous. I wanted to go on and teach you the two algebraic methods of solving simultaneous equations. And the first one I wanted to teach you is substitution. You've probably already done this without even realizing it. What it basically entails is writing one of your unknowns in terms of the other, substituting that into the other equation and solving for that unknown, and then you can sub in back in and find your other unknown. This will work whether you have two linear equations or perhaps a linear equation and a quadratic equation. Pretty much anything really that you can get one of your unknowns in terms of the other. It can be a bit fiddly sometimes if you've got a lot of fractions involved. So if you were to have a series of equations where in order to get x in terms of y or y in terms of x, you'd have a lot of fractions coming in, then probably substitution is not the way to go and the other algebraic method would probably be better. But I've deliberately chosen this example, and that's the one that we used in our graphing example, and I'm going to use it to show you substitution as well as showing you the other method, which is called elimination. So let's go ahead and we'll show you how to do this. What you need to do, first of all, is you need to, if one of the equations isn't already in the format required, we're going to adjust it. So if we take equation 2, that's the best one to work with, we can fairly easily get x in terms of y by adding 3y to both sides. We'll call that equation 3. All right, you need to either have x in terms of y or y in terms of x. Now we can sub that into the other equation. So wherever we see an x, we're going to put 3y plus 3. So 2 lots of 3y plus 3 plus our 3y is 24. We're just going to expand and simplify. So 6y plus 6 plus 3y is 24. So 9y plus 6 is 24. 9y is obviously 18, so y is 2. Now you're not actually done yet. A lot of people forget and think that they're done. They get a bit excited. They've found what y is. Well, you're not completely done yet. Now you're going to sub that back into this one. And well, you could sub it into any of the equations, but this is the most sensible one to sub it into to find what x is. So sub this into equation 3. So x is 3 times our y value plus 3, which is 6 plus 3, which is 9. And I like to then just write my solution down the bottom. X is 9 and y is 2. And that corresponds to what we found graphically. So we know that that one is correct. If you wanted to check, you could just go and put both of those into equation 1 and check that it does actually work. We've used equation 2 to get the x value there. But if we try to check that they work in equation 1, 2 times 9 is 18, plus 3 times 2, okay, is 6, and that gives you your 24. So that is in fact correct, as we hoped. Sometimes you'll be given an equation that's already in the form that's suitable to substitute. Here, equation 1's already got y in terms of x, so let's just sub that in. And wherever we see a y, we're going to put 2x plus 3. So just be a little bit careful here. So we've got 6x minus y. So we're subtracting all of this, and that equals 9. So 6x minus 2x minus 3 is 9. So 4x minus 3 is 9. 4x equals 12, so x is 3. Call that equation 3. So now we can sub that in. So sub 3 into equation 1. So y is 2 times 3 plus 3, which is 9. So we get, for our solution, x equals 3 and y equals 9. Let's just double check that both our equations are in fact satisfied by those values. So does y equal 2x plus 3? Does 9 equal 2 times 3 plus 3? Yes. 6 times 3 is 18 minus 9. Yes, that is 9, so we're all good. Okay, the great thing is you can always check if you're right by just making sure that both equations are satisfied. All right, again for this second one here, we're already given y in terms of x, so we'd be a bit silly not to use that. So we're going to sub that into equation 2. So wherever we see a y, we're going to put 3x minus 11. So 8x minus 5 times 3x minus 11 equals our 6. Okay, so wherever we saw a y, we substituted in 3x minus 11. Now just be a bit careful with your expansion here. We've got a negative outside and a negative inside. So we're going to get minus 15x plus 55 is 6. So negative 13x is negative, not negative 13x, negative 7x, I should say. My goodness, is negative 49. So x is, of course, negative 49 divided by negative 7, which is 7. Okay. Call that equation 3. Sub that into our first equation again. So our y is our 3 times x minus 11, which is 21 minus 11, which is 10. So our solution is x equals 7, y equals 10. And let's just check that we haven't accidentally made a mistake, like I almost made there, and just check that both equations are satisfied. So 3 times 7 is 21 minus 11, yes, that is 10. 8 times 7 is 56, minus 5 times 10. So 56 minus 50 does equal 6, so we're all good there. Okay, let's move on and try a few more. And what we're going to do is we're going to have to do some quadratic equation solving in a minute. Okay, so in this one we don't already have y in terms of x or x in terms of y. However, it's pretty obvious that this first equation here would be the easiest one to manipulate. If we just put the 7x, subtract that from both sides, we get y as 15 minus 7x, or you could do negative 7x plus 15, it's the same thing, it doesn't really matter. So we're going to sub that into our second equation. Wherever we see a y, we're going to do 15 minus 7x. So 3 times 15 minus 7x plus your 7x is 3. So 45 minus 21x plus 7x is 3. 45 minus 14x is 3. Negative 14x is negative 42, so x is 3. If we sub that into this equation back here, we can find the y value. So y is 15 minus 7 times 3, which is 15 minus 21, which is negative 6. So our solution here is x is 3 and y is negative 6. We can double check that by going to both of those equations and just making sure that those solutions do work. If x is 3 and y is negative 6, so negative 6 plus 7 times 3 is negative 6 plus 21. Yes, that is 15. 3 times y, so negative 18 plus 7 times 3. Yes, that is 3. So both equations are perfectly fine there. I'm going to leave number 4 for now. I think we've done enough linear functions. Let's have a look at number 5, which is a little bit more interesting. Here we have one linear function and one quadratic function. In this situation, we want to sub this into here and solve for x, but what we're actually going to be solving is a quadratic equation. So let's sub, well, whether you think of it as subbing 2 into 1 or 1 into 2, it's really the same thing. So we're saying that 5x plus 16 is x squared plus 3x plus 8. Now, the way to go with something like that is to get everything over the one side and a 0 over the other. So x squared, we're going to take away 5x, so x squared minus 2x minus 8 is 0. This is quite an easy one to factorise. We're going to get x minus 4x plus 2. So x is negative 2 or 4. Now what's going to happen here is, for each of those x values, we're going to have to find the corresponding y value. It will often happen when you have a quadratic function and a linear function that you will get two solutions. Remember, a quadratic function graphs as a parabola, a linear function graphs as a straight line. It's perfectly possible to have 2 points of intersection there. So we're going to sub 3 into 2. So when x is negative 2, y is 5 times negative 2 plus 16, which is negative 10 plus 16, which is 6. So the first solution is x is 2, y is 6. The second one, when x is 4, y is 5 times 4 plus 16, which is 20 plus 16, which is 36. So x equals 4, y equals 36. Why did I write 14 there? Sorry about that. X is 4 and y is 36. Now we can check that that works, particularly, well, we want to check in our first equation because we've used our second equation to find those y values. When x is negative 2, y will be negative 2 squared, which is 4, minus 6, right, which is negative 2, plus 8, which is 6, so that's correct. When x is 4, x squared is 16, plus 3 times 4, so 16 plus 12 is 28, plus 8, yep, is 36. So both of those solutions are in fact correct. They check out okay. So that's one of our solutions and that's our other solution. Here we've got yet a different situation again, where here's our equation 1 and here's our equation 2. It's probably 6 of one and half a dozen of the other, which one you want to sub into which. I'd be inclined to use the linear equation here and just rearrange that to write y equals 4x plus 10. Now we're going to sub that into our first equation. So we're going to get x times 4x plus 10 is negative 6. Now in a situation like this, we need to expand and bring everything over the one side because we're going to have another quadratic equation, aren't we? So we're going to get 4x squared plus 10x equals negative 6. So 4x squared plus 10x plus 6 is 0. I would be inclined to divide everything through by 2 just to make our numbers a little bit easier to work with. perfectly okay to do that, as long as you do it to every term. Now we want to divide up that middle term. We want two numbers that multiply to give 6 and add to give 5. So 3 and 2 will work. So if we divide that up into a 2x and a 3x, so we get 2x, x plus 1 plus 3, x plus 1 is 0. So x plus 1, 2x plus 3 is 0. So x is either -1 or -3 on 2. Now for each of those x values, you are going to substitute in and work out what your y is. So we'll call this bit of information 4 and come over here. So sub 4 into 3. So y equals, so when x is -1, y is going to be 4 times -1 plus 10, which is 6. When x is -3 on 2, y is going to be 4 times -3 on 2 plus 10, which is 4. Yes. Okay, so our solutions are x is -1, y is 6. And x is -3 on 2, y is 4. And we can check that they work, particularly in the equation that we haven't just used to find our second unknown. So if we just check that they work in the first equation, is x times y equal to -6? Well, -1 times 6, yes, that is -6. Is -3 on 2 times 4 -6? Well, -3 on 2 times 4 on 1, that goes in twice. So yes, it does work. So they both work, so we're all good there.